This is page 51. You're looking at this cone, and it says that it wants you to, based on the fact that the volume and the surface area are equal, to find the value of the radius. So, first of all, you do not have to memorize these formulas. These formulas are provided for you. And so, I know that the volume and the surface area are equal, which means that this equation, 1/3 pi r squared h, has to be equal to this equation, pi r s plus pi r squared. Okay, I know that the slant, which is right here, and is represented right here in the equation, that slant is already written out in terms of r. It's 4r over 3. So I'm going to rewrite this equation. So 1/3 pi r squared h equals pi r, and again that slant is 4r over 3 plus pi r squared. Okay, I'm going to simplify just a little bit. 1/3 pi r squared h is equal to, I'm going to grab all of these. I've got, just make sure I catch them all here. 4 times pi, and then r times r is going to give me r squared, so I've covered both of those, and now that's over 3 plus pi r squared. All right, looking at this this equation, an interesting thing I'm noticing, there's an r squared there, an r squared there, and an r squared there. Also, there are fractions. The first thing I'm going to talk about is the fractions. I've got a third and a third here. I don't like dealing with fractions. It increases the likelihood that I make a mistake. And so I'm going to multiply every term on both sides by 3. My rationale is there, 3 into 3 gives me 1. This becomes pi r squared h equals to, those 3's cancel, which gives me 4 pi r squared plus, and now there's nothing to cancel here, so this just becomes 3 pi r squared. Okay, so that was the first thing I noticed. I wanted to get rid of the fractions just to decrease my likelihood for error. The second thing I'm noticing is I've got here an r squared, here's an r squared, and here's an r squared. Now, normally when we're solving equations, we are not allowed to divide by a variable if we don't know what that variable is, because the variable, should it be 0, would make that undefined. However, and I don't know what r is, but I do know it's not 0 because the radius represents a thing that actually exists. This is a figure that has happened. It's right here and I can see it, so I know that the radius is not 0. So if the radius I know for sure is not 0, in this case I am allowed to divide through by r squared. And again, I would not be allowed to do this unless I knew r cannot be 0. And now I have pi h is equal to 4 pi plus 3 pi. So pi h is equal to 7 pi. And if I divide by pi, I actually now know that the height has to be 7. All right, so let's go back here. The height is definitely 7. And let's look at something else that I maybe know. If you look, hold on. So I'm going to just say goodbye to you, and because I know you're 7. So now I've got this another secondary equation that I could use, because I know that this right here is a right triangle. Okay, that's not very pretty, but here we go. This right here is a right triangle. So I do know the Pythagorean theorem is true about it. So let's see what happens when I do that. So let's do 7 squared plus r squared is equal to 4r over 3 quantity squared. That gives me 49 plus r squared is equal to 16r squared over 9. Now, just the same as how I didn't want the 3's in the denominator previously, I'm going to go ahead and do this and get rid of that over 9 situation. So 49 times 9, I'm just going to do in my calculator. 49 times 9 is 441 plus 9r squared is equal to 16r squared. So now I'm going to subtract 9r squared from both sides. And 441 is equal to 7r squared. Divide both sides by 7. Okay, and I've got 63 is equal to r squared. So I'm going to square root both sides. The square root of 63 is the same as the square root of 9 plus 7. And I know that the square root of 9 comes out as 3. So that equals to 3 times the square root of 7. The answer is A.